Okay, next we're going to talk about for loops. So in the last lecture we saw that the keyword while allows you to write some code where the physical order of statements is different from the logical order that they're executed. In other words, we were able to repeat some code without having to copy and paste it many times. Copying and pasting code is a really bad idea, because if you do end up copying and pasting a lot of code, you might realize later on that you had an error in that code. And then it's up to you, the programmer, to have to remember every single place where you pasted the code to go and fix that error. Okay, and it's not likely that you'll be able to remember every single place where you pasted that code. So soon we're going to talk about these things called functions, and they are used almost exclusively so that we don't have to copy and paste code. Okay, but today I want to continue to talk about loops. While loops are a fundamental part of most programming languages, but they have one main problem. Okay, the syntax of the while loop has one big problem. The code to control the loop might be spread out vertically so that it's hard to see how the loop works. Okay, so remember this code here. This is going to print my name 5 times. But what if the code was spread out so that we couldn't see the 3 important statements on the screen? In other words, maybe we do some interesting stuff here, from here to here, and then maybe the loop body isn't quite so simple, so we're doing some interesting stuff there, maybe to here. Okay, and now it's really hard to see the 3 really important parts of a loop, because they might not all fit on a single screen. Okay, well, what are the 3 really important parts of a while loop? Well, we have the initialization of the loop counter. Right, that's really important. Next we have the loop test. That's really important. That helps control how the loop works. And then lastly we have the updating of the loop counter. Okay. And again, there might be pages and pages worth of code in between these 3 different points. And then again, it's kind of on one computer screen, it's hard to see all 3 pieces at the exact same time. And since all 3 pieces contribute to how the loop works, it'd be really nice if we could see all those things on a single screen. Okay, and this is where the for loop comes in handy. A for loop is exactly equivalent to a while loop, but it puts those 3 important pieces that control the loop together on a single line. Now again, the compiler doesn't care if we spread these out over multiple screens worth of real estate here. The for loop is really beneficial to humans who have to read the code. So the compiler is totally fine with this, but for a human reading the code, it's much more readable if we use this thing called a for loop. And when I talk about for loops are really only used for count-controlled loops. Those are loops where we're counting iterations, and we're going to do something until we meet some number of iterations. Okay, so here's the syntax for a for loop. First of all, there's a keyword for. Okay, so instead of while, you use the word for. Then we have the initialization statement, followed by a semicolon, then the loop test, another semicolon, an update statement, and then finally a loop body. So the initialization statement is executed exactly once, when the flow of control first reaches the for. Okay, next, the loop test is checked. If it evaluates to true, then the entire loop body is executed. And when the flow of control gets to the end of the loop body, the ending curly brace, the update statement is executed. Okay. Finally, the flow of control jumps back to the top of the loop, and the loop test is evaluated again. If it's still true, the loop body will be executed again, and if not, the flow of control will jump to the first statement outside the loop body. Okay, so let's look at a real example here. Okay, so on the left here we have the original program, okay, using the while and the counter. Here we have a for loop that has basically those same three pieces, but all on the same line. Okay. And what I'm saying is these two things are exactly equivalent. The compiler doesn't care which one we use, but for count control loops, this one, the for loop, is much more readable for humans. Okay, so let me just prove to you that this actually works. Okay, so this should print out my name 5 times. Again, if I want to print out my name 50 times, well, again, I just have to change that one line. Okay, and now there's my name 50 times. Okay, so like I said, this allows us to put all the code to control the loop in one place, the for statement, and it allows us to focus on what we want to repeat inside the loop body. So notice in here I didn't have to remember to update the counter. So it's less likely that we're going to forget to update that loop counter at the end of the loop. And this is actually a typical error that we programmers make, because when we're writing the loop body, we're really focusing on what needs to be repeated, not on controlling the loop. So moving that update statement outside of the loop body is I think it helps the programmer kind of construct their loop. Okay, so let's look at a slightly more complex example. Again, this comes from, I think we did the exact same program in the last lecture. This is the one that's going to do something 1,000,000,000 times. Okay, so 1,000 times 1,000 times 1,000 is a billion. And you have to think, for each iteration of the outer loop, we're going to execute this code, which is, there's 1,000 iterations of the inner one and 1,000 more of the innermost one. Okay, so whatever's inside the innermost one is going to execute 1,000 times 1,000 times 1,000, or 1,000,000,000 times. And we should see this takes about a second or so. And it should sum up to 1 billion. And this code is even shorter than before because, again, we're declaring the variable and the update and the loop test all together on one line. Okay, so these 6 or so lines of code cause a tremendous amount of work to be done by the computer. That's what makes computer programming so powerful. With just a little bit of work from us, we can ask the computer to do just a ridiculous amount of work. So the use of the counter names in this case, I, J, and K, is somewhat arbitrary, but I've noticed with a good number of programmers, they use these values for loop counters, usually starting with I. And I do this myself. Instead of typing out the names counter 1 and counter 2, I guess we do this because we're a little bit lazy, and I is a lot shorter to type than counter 1 or counter 2. However, if there is a meaningful name for a counter, you should definitely use it. So let me show you one more program, again from, I think we did this one in the last lecture as well, where here we're doing something really with row and column numbers. So here we have a nested for loop. That's perfectly fine to nest for loops. And we'll see, we see a bunch of row and column numbers. Maybe I can reduce this to just the row number and the column number. Okay, so we have from 00 to 99, 10 rows, 10 columns. Okay, again, when the flow of control gets here, you have to always picture, and sometimes I actually draw a picture of this variable called row, and we set it equal to 0. Then we do the loop test. Is 0 less than or equal to 9? That's true. So we're going to go and execute the entire loop body, which happens to include another loop, where we declare another variable called column, set it equal to 0, and we say is 0 less than or equal to 9? That's true. So we're going to print out the first row and column. when we come to this ending curly brace, remember we're going to go back to this, or I'm sorry, we're going to increase column by 1. Okay, so the curly braces are really important here. The ending curly brace for the inner 4 means we update the column, and now column is going to be equal to 1. And we say is 1 less than or equal to 9? That's true. So we're going to, the row hasn't changed, but the column is now 1 more. So it should go from 0, 0 to 0, 1 to 0, 2. Okay. Only when the column is equal to 10, right, is 10 less than or equal to 9, that's false. That's when we'll end the line. That's when we know the first row is complete. And then we come to the ending curly brace for this 4, and now row is going to go from 0 to 1. And we're going to see is 1 less than or equal to 9? That's true. So we're going to do this entire thing again. Right? We're going to print out 10 columns, but this time the row number has changed. Now, you'll notice on the second row, all of the numbers start with a 1. Right? And we do that for the 20s, the 30s, the 40s, all the way up to the 90s. Okay, so that's a for loop, and I find myself using for loops quite a bit because it turns out most loops are count controlled, and if I'm writing a count controlled loop, I like the for syntax because it puts all the really important things together on a single line. And again, the compiler doesn't really care. The compiler doesn't. It'll probably turn this for loop into the exact same for loop as this one. Right, so the compiler turns code into machine instructions. If we gave the compiler this or this, it would probably result in the exact same machine instructions. But what I'm claiming is this is easier to read for us humans. And for that reason, I use for loops pretty much all the time.